These are the notes, flipbook notes for 622. This will go at the top of 622 right under your sum and difference formulas. You'll see both of these types of questions on either your quiz or your exam using sum and angle difference. So let's say we have evaluate cosine of 105 degrees. Well, you don't know where 105 is on the unit circle, but you do know two angles that either add or subtract to 105. Probably adding would be easiest. So 60 and 45, they'll give you 105, and both of those are on the unit circle. So if we go ahead and expand this, we get cosine of 60 times cosine of 45. And we're doing cosine, so we're going to do the opposite. So subtract sine of 60, sine of 45. Now that we know this, cosine of 60, that's your x coordinate at 60, 1/2, rad 2 over 2. Sine of 60, which is rad 3 over 2. Sine of 45, rad 2 over 2. Multiply over 4, minus rad 3 times rad 2, rad 6 over 4. Combine our like terms, we get rad 2 minus rad 6 all over 4. I know that doesn't look pretty, but that's your final answer. If we were to type this in our calculator, we'd end up getting x approximately equals negative 0.26, which will make a bit more conceptual sense. So what we mean here is if I evaluate cosine of 105, I'll get about negative 0.26. Well, what does this mean? Cosine of 105 is about, got a little better here. 105 is about here on the unit circle, and if we think about 105 degrees and we think of cosine is your x coordinate. So what is your x coordinate at negative 105 degrees? It's about negative 0.26. That's the distance, which makes sense with the unit circle. That's the first part of your notes. The cool thing about this is this would also give you the same answer if you did something like this. Cosine of 150 minus 45, or cosine of let's say 135 minus 30. Two angles you know, you should get the same answer any way you do it. This is really cool because you can take values that you know to find values that you don't. Bottom of the flip book, another type of example, but using triangles looks like this. So this will go on the bottom of your flip book. Suppose alpha is an angle in quadrant 2, and beta is an angle in quadrant 3, such that sine of alpha is equal to 4 over 5, and cosine of beta equals negative 3 over 4. Alright, so we saw problems like this in chapter 4. The idea here was this: when you approach something like this, you need to look at the fractions. Are they familiar? Are they on the unit circle? If they're not, like 4 over 5 or negative 3 over 4, it probably means they're not on the unit circle, and instead that they are on, that you need to draw triangles in those appropriate quadrants. They're probably outside of the unit circle. So go ahead and draw two triangles here, one in quadrant 3, quadrant 2, and I'll do another in quadrant 4. We're not going to draw them to scale. I'm going to fill in these numbers. And this is beta. Sine is your opposite of hypotenuse, so we say 4 over 5. Sine of alpha, cosine of beta is negative 3 over 4. So I know that 3 over 4. We do the Pythagorean theorem on this, we get negative rad 7 here. And then for this one, it just so happens to work out that this side is also negative 3 because it's a 3, 4, 5 triangle. Now, sometimes that's not the case. The triangles are different sides, so it's important that you do the Pythagorean theorem here to find the missing side. That's how we find those two. Now that we have all that information, we're going to evaluate a couple things. First one, evaluate sine of alpha minus beta. Well, the only way we can evaluate this is if we expand it. So we know that sine of alpha minus beta is equal to sine of alpha, cosine of beta, and sine uses the same sign, sine of beta. So sine of alpha, we know from the beginning, we're going to have 4 fractions here. Sine of alpha is 4 over 5. Cosine of beta, negative 3 over 4. We have that from what we're given, and then we have cosine of alpha, so we can look at our alpha triangle here. Cosine is adjacent over hypotenuse, so it's negative 3 over 5, and negative 3 over 5, and then negative rad 7 over 4. Now you gotta be really careful with the signs here. So we can multiply across, we get negative 12 over 20, minus, now we're gonna multiply these two together. Just keep this in parentheses, negative 3 times negative 7 is positive 3 rad 7, all over 20, we get 12 minus 3 rad 7, all over 20. Boom. That's that solution. Second question here. Evaluate cosine of alpha plus beta. Expanding this, we get cosine alpha, cosine beta. That screaming you hear in the background is Kaiser cafeteria children screaming. Look at your dedicated teacher doing work while it's possible. Cosine alpha, cosine beta, so you can do well on your quiz. Cosine is the opposite sign, so instead of adding, we're subtracting sine of alpha. Same thing here. You're going to have 4 fractions. Go back to your triangles to figure these out. Setting it all up. Cosine alpha, negative 3 over 5. Cosine beta, negative 3 over 4. Minus 4 over 5. And negative rad 7 over 4. Multiply, we get 9 over 20. Minus, be careful with your parentheses again. Here's where the mistakes are made. Minus, let's go back here, a negative 4 rad 7. And because we have those two negatives become a positive. We have 9 plus 4 rad 7 all over 20. Alright, put these in your flipbook notes. Practice them for the quiz on, I guess for you guys, Tuesday, if I haven't seen it yet. Tuesday during office hours.